Okay, this is question 7 on Additional Maths 2016, WJC. We're going to have a look at coordinate geometry question here. So we've got the coordinates of the points F and G are negative 2, 14 and 4, 6, respectively. Calculate the length of the line FG. So if we're using a line FG and we're looking for the length, what we want to use is our Pythagoras formula. Now, if you'd rather, you might rather just draw out a little sketch and draw a right angle triangle and work from there. But here, x2 minus x1 plus squared, excuse me, plus y2 minus y1 all squared. All we have to do is to choose which one of these is going to be x1, y1, which one's going to be x2, y2. It makes sense that the second one is x2, y2, and the first one is x1, y1, so that's what I'm going to go with. So this is going to be the square root of, okay, x2 is going to be the 4, so I'm going to do the 4, take away negative 2, squared, plus 6, take away 14, all squared. And then you can go to your calculator and work this out. So you've got the square root of 4, take away negative 2, all squared. Okay, B, we got find the gradient of the straight line that passes through the points F and G. So the formula for the gradient for FG is going to be y2 minus y1 over x2 minus x1. So I may as well stick with the y2s and the x2s that we have from last time. So y2 is going to be 6, take away y1 was 14. So we get 6, take away 14, all over x2, which is 4, take away negative 2. So we get 4, take away negative 2. So 6 take away 14 is negative. Okay, part C. Find the equation of the straight line that passes through the midpoint of the line FG. So we're dealing with the midpoint of FG and perpendicular to the line FG. Okay, so let's find a point. So if I want to find the equation of a straight line, the equation I'm going to use is minus y1 equals m bracket x minus x1. So I need, from my y1 and my x1, a coordinate of a point on the line, in this case, the straight line that I'm working with here, the equation of the straight line, and the gradient. Okay, and we don't know either at the moment, but we do know that it passes through the midpoint of the line FG. So if we look at the formula for the midpoint, then I'm going to add my x's together and halve it, add my y's together and halve it. So I get x1. So again, where am I using? I'm using these ones up here. So my x1 is going to be negative 2 plus 4. So I'm adding the x's together, halving it, and then adding the y's up. So 14, add 6, and halving them. So this is the midpoint. So it's going to be negative 2 plus 4 is 2 divided by 2 is 1. 14 plus 6 is 20. 20 divided by 2 is 10. So there's my midpoint of FG. Now I need to know the gradient. So the gradient of FG is perpendicular to the line. Oh, it's not the gradient of FG, sorry. It's the gradient of the line that we're looking for. Is perpendicular to FG. So if it's perpendicular, that means that its gradient is the negative reciprocal of FG's. Well, FG has a gradient of negative 4/3. So the perpendicular gradient, instead of negative 4/3, is positive 3 quarters. Okay, so now my equation of which I can use this. So my y is going to be 10, or my y1 I should say is going to be 10. My x1 is going to be 1, and my gradient is going to be 3/4. So I get y minus 10 equals 3/4 x minus 1. And you're asked to put it in the form ax plus by plus c, where they are all integers. So let's start by multiplying through by this 4. So I get 4y minus 40 equals, and if the 4 is gone, I can expand this bracket by 3. So I get 3x minus 3. So we want ax plus by plus c. So let's make that equal to 0. So I can get negative 3x plus 4y. And if I add 3 to both sides, I get negative 37. And that's in the format that they want. So a, b, and c are integers. And it's in the right format.